almost 100 years, scientists have known our universe is haunted. There's an invisible substance that makes up 85% of, well, everything, and we've never, ever seen it. Until, maybe, now. There's a new signal buried deep in 15 years of old data that might just be the first time humanity has ever laid eyes on the unseeable. The hunt for dark matter, it might finally be over.
And look, this isn't just some abstract academic question, right? The answer to this determines the fate of our own galaxy, the very shape of the entire cosmos. I mean, everything we think we know about reality is built on a foundation of something we can't touch or see, an invisible scaffold that we've been desperately trying to find. And after decades of just silence, it seems like something at the heart of the Milky Way is finally calling back. To really wrap your head around how deep this mystery goes, you have to accept a pretty shocking truth. Just take everything you can see, every star, every planet, every galaxy in those beautiful telescope pictures, and understand that it's all just cosmic crumbs, a tiny 15% sliver of all the matter out there. The other 85% is this dark matter. And it's not dark like a shadow. It's dark because it is completely, utterly invisible to us. That means you, me, this planet, we're the exception, not the rule. We're the leftovers. The universe is completely dominated by a substance that is streaming through your body right now by the trillions, and you don't feel a single thing. It's completely unnoticed.
You know, the first clues to this cosmic crime scene started popping up almost a century ago. First, back in the 1930s, astronomers saw whole clusters of galaxies moving with impossible speed. They should have just torn themselves to shreds. Then, in the 70s, the astronomer Vera Rubin noticed that stars on the edges of galaxies were spinning way too fast. It was like watching a merry-go-round spin so fast the horses should fly off into the night, but they just didn't. Something invisible was holding them tight.
And that's the key right there. Without this extra gravitational glue, our own Milky Way would just disintegrate. The stars, including our sun, would be flung out into the empty void. This invisible stuff isn't just in the universe. It is the scaffold that the visible universe is built on. But here's where the mystery really starts to get strained.
So the search turned into this huge cosmic game of guess who? Scientists lined up all the possible suspects. Could it be a bazillion tiny black holes? Nah, we would have seen how their gravity bent light from the early universe. Okay, what about those ghostly particles called neutrinos? Nope, they move way too fast. They're what we'd call hot dark matter. They wouldn't clump together to form the gravitational anchors that we see holding galaxies together. One by one, every suspect got eliminated until only one was left standing.
And that prime suspect's name was the WIMP, the Weakly Interacting Massive Particle. For decades, this was the perfect culprit. It was a particle that's heavy, slow-moving, and almost completely antisocial. It ignores us, it ignores our instruments, it ignores pretty much everything. It had the right mass, it had the right gravity, all it was missing was the smoking gun.
But theories predicted WIMPs had a secret, a tell. You see, while they're invisible most of the time, if two of them were to ever collide, poof, they should annihilate each other in a flash of pure energy, a very specific kind of high-energy light called gamma rays. For years, we have been staring into the dark, just waiting for that flash. And then, well, what scientists found next changed everything.
This is it, the big break in the case. A researcher decided to go back, dig through 15 years of archived data from a gamma-ray space telescope looking right into the heart of our own galaxy. And what they found, hiding in all that noise, was astonishing. After painstakingly, carefully removing every known source of gamma rays from the data, every pulsar, every black hole flare, all of it, there was still something left over, a faint, spherical glow. And this glow peaked at a very specific energy, 20 giga-electron volts. Why does that number matter? Because that is the exact energy you would expect to see from a WIMP getting annihilated.
So, does the signal match the suspect? Let's check the boxes. First, the glow was spherically symmetric, exactly what you'd expect from a halo of dark matter surrounding the galactic center. Check. Second, its energy signature was a perfect match for WIMP annihilation. Check. And third, and this is the big one, there was no other explanation. No known star or cosmic object could be making this signal. It looked like we'd finally found our ghost.
I mean, if this is real, it is one of the biggest discoveries in the history of science, period. The first time we have ever seen the invisible universe. But in science, extraordinary claims require extraordinary proof.
And this is where the story gets strange and the case starts to get a little shaky. So what is this? A landmark discovery or a statistical ghost? The excitement is there because, yeah, it's a perfect match for our prime suspect. But the skepticism comes from how it was found. You see, this glow wasn't seen directly. It's just what was left over after scientists built a super complex model of the galactic center and then subtracted that model from the data. What if their model was just a little bit wrong?
And the doubts are pretty serious. For one thing, this data has been public for over a decade. Why is this signal only showing up now? And let's be honest, history is a harsh teacher here. We have had supposed dark matter signals before that just turned out to be pulsars or other weird but totally normal objects that we just hadn't accounted for yet.
And some critics are saying the method itself basically guarantees you'll find something. Think about it. If you subtract a bunch of really complex, messy shapes from your data, and then you specifically go looking for a simple sphere in what's left over, you're probably going to find one. It's the ultimate risk of seeing a pattern in the static.
But here's the biggest problem for our prime suspect, the biggest hole in the case. For decades, we have built these enormous detectors buried deep underground to shield them from all radiation, and they've just been listening for the single ping of one WIMP particle bumping into one of our atoms. And after all that time, all that money, we've heard nothing. Absolute deafening silence. The WIMP, it seems, has a perfect alibi.
So if our prime suspect is innocent, where do the cosmic detectives look next? Well, this is what science does best. When a beautiful theory gets killed by an ugly fact, you don't just give up. You go look for a new, even stranger, suspect.
So meet the new leading candidate, the axion, and it is the polar opposite of a WIMP. It's not some heavy little bullet. It's an unbelievably light wave. So light, in fact, that it wouldn't even really act like a particle at all. Instead, all the axions in the universe would merge together into a single vast invisible ocean of dark matter.
Just think about that for a second. We spent decades looking for trillions of tiny, heavy bullets whizzing through space. The new thinking is that maybe, just maybe, we're living inside a single, vast, invisible ocean. In this new picture, our entire galaxy is just a buoy, floating on the surface of a dark matter sea.
So, while that gamma-ray signal remains this tantalizing what if, the case is far from closed. The hunt for dark matter has shown us just how little we truly see. Whether the answer turns out to be WIMPs or axions or something our minds can't even comprehend yet, one fact is certain. 85% of the stuff that makes up our reality is a complete and total ghost. And that makes you wonder, what else is the universe hiding right in plain sight?